Hi class, in this lecture here I just want to give you an introduction to section 2.3. Now there's going to be a lot of additional topics in section 2.3 that I'm not going to cover in this video. This video here is just going to be kind of a short introduction to what we call prime numbers. You should read the rest of the textbook section 2.3 to get the rest of the concepts in for prime numbers. Okay, so section 2.3 is called prime cuts of numbers, or how the prime numbers are the building blocks of all other natural numbers. So as we've done before in the previous lecture, let's start with a question. So can you write the number 71 as the product of two smaller numbers? So what that means is 71 something like 23 times 3 or something? No, 23 times 3 is 69. But so it turns out that you cannot write 71 as the product of two smaller numbers. The only two numbers, okay, two natural numbers that multiply to be 71 are the numbers 1 and 71 itself. But 71 is not a smaller number. So when you have a case like that you can only divide a number by itself in 1, these are what we call prime numbers. So a natural number greater than 1 is a prime number if it cannot be expressed as the product of two smaller natural numbers. So the list I have here is all the natural numbers under 100. So 2, 3, 5, 7, 11, 13, 17, 19, and so on. All these numbers can only be expressed as the product of itself and 1. The cool thing about prime numbers is it turns out that you can do what's called prime factorization of all other natural numbers. So every natural number greater than 1 is either a prime number, going back, like these numbers here, or it can be expressed as a product of prime numbers. Let me give you an example of what I mean by the product of prime numbers. All right, so write the following numbers as products of prime numbers. So consider the number 12. All right, well, can I write 12 as 4 times 3? Yeah, sure, that equals 12. But then think of the number 4. Is 4 a prime number? No, but is 4 2 times 2? So don't forget the 3 there. So 12 is equivalent to or equal to 2 times 2 times 3. So if you look, 2 and 3 are all prime numbers. So I could write 12 as a product of prime numbers. So if you look at 30, is 30 the same thing as 3 times 10? Yes. Is 10 a prime number? No. What can we write 10 as? Can we write 10 as 5 times 2 or 2 times 5? Yeah, we can. And so look, the numbers 2, 3, and 5 are all prime numbers. So any number you pick, let's try it for 40. 40 is 4 times 10. Well, 4 is equal to 2 times 2, and 10 is equal to 2 times 5. So any number you pick can be written as the product that's not a prime number itself, can be written as the product of prime numbers. Turns out what's great about prime numbers is there's actually an infinite many number of prime numbers. Prime numbers are still being discovered, in today's world. We haven't discovered all of them. Obviously, we can't because there's an infinite number of them, but they go on forever and ever. They keep getting larger and larger. All right, so this quick video just gave you an introduction to what prime numbers are. Please be sure to read the rest of this section in the textbook to cover the rest of the topics.